Hello everybody. In this question, there's a curve C, and that curve is parameterized by the vector valued function rt, and this parameterization involves a parameter, a constant actually, omega, and the question says find the value of omega, so the curve is parameterized by arc length, or explain why no such value for omega exists. Okay, so a curve is parameterized by arc length if and only if magnitude of its derivative is equal to 1 for all t. Okay, so now let's find this. So we need to find the derivative of this vector valued function. That means we are going to take derivative of each coordinate. Okay, so this coordinate is given by 3 cosine omega t squared, and let's take its derivative. So if we take the derivative, it's going to be minus 3 cosine omega t squared, and then because of the chain rule, we will multiply with the derivative of omega t squared, which is 2 omega t. Okay, and then for the same thing for the second coordinate, it's going to be minus 3 this was sine. Okay, so we were taking derivative of cosine, and derivative of cosine is minus sine, so that's why it is minus 3 sine, and then multiplied with the derivative of the thing that is inside of the cosine. So let's take the derivative of the second coordinate. It's going to be minus 3 cosine omega t squared, and then we have the derivative of the thing inside, which is 2 omega t again. Okay, after we multiply these things, we will get 6 minus 6 omega t sine omega t squared, and then minus 6 omega t cosine omega t squared. Okay, so we need to find the magnitude of the derivative. Okay, magnitude of the derivative, you take the square of each coordinates, add them up, and then take square root. So it's going to be square root of minus 6 omega t sine omega t squared square, and then plus minus 6 omega t cosine omega t squared. Okay, so this is going to be, if you take the square of this thing, you will get 36 omega squared t squared, and then sine square of omega t squared, and then 36 omega squared t squared cosine square of omega t squared. Okay, so as you see, we have this thing here and then the same thing here, so that means we can take into parentheses of the we can take the expression into parentheses of 36 omega squared t squared, and in the parentheses it's going to be sine square omega t squared plus cosine square omega t squared, and this thing is 1, right? So that is basically 36 omega squared t squared, and if we take the square root, this is going to be 6 absolute value of omega times absolute value of t, but the t is changing from 0 to 2 pi. It is never negative, so the absolute value is going to be just t for absolute value of t, so this is going to be 6 absolute value of omega times t. Okay, and we said, let's write it here first. R prime, magnitude of r prime t is equal to 6 omega t. Okay, and to be parameterized by arc length, we must have the magnitude of the derivative of the parameterization should be 1 for all t, and if we let 6 omega t to be 1, that implies then omega must be 1 over 60, but this is a constant, right? And this is a function, so this cannot happen. This can't happen. So no such value of omega exists. Okay, so then no matter what we give a value to omega, this parameterization is never going to be arc length parameterized. Okay, so that's it.